Hello and welcome to chapter 2 of circuit theory. So in this chapter we will learn about the voltage, the current dividers and Kirchhoff law. Okay, before we go into this Kirchhoff law, we will need to know about the nodes, branches and loops. Okay, as you can see in this diagram, it is a circuit with 5 branches where one is the source, one is the resistor, one is the capacitor, and then the other is another resistor and a diode over here. So this is a branch is a single electrical or element or device. As you can see, there are 5 different branches over here. But with nodes, as you can see from the second diagram, nodes is denoted, can be defined as a connection point between 2 or more branches. Okay, as you can see, there are 3 branches over here. Okay, but the nodes are defined as the one connected to electrical element over here. Okay, as you can see, the resistor and capacitor is connected in a parallel circuit, and these 2 points are counted as a node. There are 2 nodes over here, but then there is another one over here where the resistor is connected in a series. Okay, these 2 resistors are 2 different elements, so the both of them are connected in between, and there is another node over there. So that is nodes and branches. What about a loop? A loop is a closed path. An independent loop is one that contains at least one element not contained in another loop. Okay, as you can see from this uh, the diagram itself, you can see that it is one closed circuit. The voltage, the resistor, and resistor 2. So if we start at any point in the circuit, node proceed through the connected electrical device back to the point node from which we started without crossing a node more than one time, we form a closed path. Okay, this is a loop. Okay, in this example, how many branches nodes does the circuit in figure 2.14 have? Okay, so in this figure, we see there are 5 elements. Resistor 1, resistor 2, resistor 3, the voltage source, and resistor 4. So we understand that there is 5 branches, 1, 2, 3, 4, 5. Okay, there are 5 branches over here. But how about a node? We do not count the branches itself for the nodes. We count the things that connected to it. Okay, and one of them is this one. So all of this is connected into one node over here. R1, R2, and R3 are connected in one node. So this is node number 1. Okay, this one is the same. So R3 is connected with voltage source and connected with R4 over here. So this is another node. And finally, the third node is over here. All of them are connected in the bottom. As you can see from the example answer itself, we are correct. There are 5 branches, 1, 2, 3, 4, 5. And there are 3 nodes identified as 1, 2, and 3 over here because they are connected to one point at the bottom. Okay, so we would like to determine how the current divide split in this circuit. So over here, there is a circuit with 2 resistors connected in parallel. So in this ruling where current, if it's in parallel, the current splits into 2 values. It is not the same value as the main current over here. It splits into 2. But for voltage, if resistance is connected in parallel, the voltage in R1 and R2 is the same. For example, if this is voltage 12 volts, the voltage in R1 is still 12 volts, the voltage in R2 is still 12 volts. Only the value of current is different. So to calculate that, we will use this to calculate the total resistance in this circuit. Okay, we can still use the equation from the previous chapter where 1 over Req equal to 1 over R1 plus 1 over R2. Well, we can also use this equation to find the resistance in parallel, where equals to R1 times R2 divide R1 plus R2. So that is the equation to find the total resistance in the circuit. We'll go find the current in the next topic. So see you in the next video.